Hello everyone, welcome to my new science school physics class. In this class, we are going to discuss dimension of formula of those drive quantity we discussed in the last class. So if you haven't watched the last lesson, it's good to see the lesson before watching this one, because you understand it better by seeing drive quantity or the lesson we did on quantity. Dimension of formula in physics help us to see how drive quantity depend on fundamental quantity. As we discussed earlier, we said that drive quantity are those quantities that depend on fundamental quantities. Mainly, the fundamental quantity we always talk about are mass. Let's start with mass. So mass is 1, then we have the second is length. This is length. Then the last one is time. These are three fundamental quantities that almost all the drive quantities must have one of these three. So these three are chiefly considered as fundamental quantities, even though there are some like temperature and electric current are also fundamental quantities, but these three are the main ones that are always used to drive quantity. So let's use symbols for these three quantities. We have mass. Let's just write M for mass. Then let's write L for length. Then let's write T for time. When we use these alphabet or symbols to represent these quantities, then we also put them in the formula for a drive quantity. For example, formula that tell us about formula of area. Formula of an area, let's say of maybe square or of a rectangle. Let's just say area. So area A, as we said, the formula is length times length. Now instead of writing length in full, we just write L then times L. By writing L times L, according to laws of indices, we know that L times L can be written as L raised power of 2. So this L raised power of 2 now is the formula for area, but this is in terms of dimension. So if I ask you what is dimension of an area, maybe of an object, we just say area is equal to L raised power of 2. Let's say A is equal to A raised power of 2. So this L raised power of 2 is dimension for area, even though this area, this L raised power of 2, we use the actual, or we use the letter that represent the whole name of the quantity, which is length. So this is the dimension. Is very, very simple, but this by writing this in terms of the initials or the symbol that represent the full name of the quantity will tell us what is the quantity that is being used to drive this area. Because now I understand that yes, it's just area times, it's just length times length, which is L raised power of 2 that will make drive quantity area. In other words, I can say we use the actual quantity, not their unit, in order to represent formula of a drive quantity. So we use the actual initial of the quantity, not the unit, because basically we use area as let's say meter times meter, which is m times m, let's say m square. This is the unit of an area, and still is the formula, because they will tell you what will you use to get the area. So, but in terms of dimension, instead of us to use the unit, we just use the initials of the actual quantity instead of the just the unit that is here written for the area. So let's go to the next formula. We have volume. Volume is fundamental quantity, which has the formula as length times length times length times length. I mean length times length 3 times. So we have length. Now this the dimension, but this one is we wrote the whole, we wrote the full name of the quantity, which is length. So we just we're supposed to use the initials of the quantity. Instead of us writing length, we just write L. So volume V is equal to L times L times L. And if we can remember, according to laws of indices, or one of the laws of indices says that V, when we have alphabet multiplying alphabet, or an alphabet multiplied itself 3 times, we just write it as L raised power of 3. So instead of us saying L times L times L, just say L raised power of 3. And this L raised power of 3 is the dimension of volume. We mean when you are asked what's the dimension of volume, just say L raised power of 3. Next, which is velocity. Velocity is equal to velocity is equal to distance or displacement. Let's say displacement all over time. Now, what is displacement? If you measure displacement of an object, what quantity are you actually measuring? You are measuring length. So displacement now is length. The quantity for distance is length. So the fundamental quantity is length. Now length, we can just write L instead of writing it in full. So we have length all over time, which is L over T. At the end of the day, if we have this, according to one of the laws of indices, says that this can be written as L T raised power of minus 1. How? This is in indices, or you need to know indices for you to understand this very well. That's why we always emphasize all those that are watching our videos, they need to understand our the basic calculations, those lessons that we talked about, how to do basic mathematics operations, including a change of the formula, a fraction, clearing bracket, all that. So we discussed them in details in our lessons called basis of calculations, so you need to check them out. So this the final this dimension of velocity. Now we have dimension of velocity. Let's do for acceleration, which is A is equal to V minus U all over time. We have the we have the dimension of velocity. We said velocity has a dimension of L T raised power of minus 1 or negative 1. Now V minus, don't be confused here, V minus U, the answer will always be in velocity. Let's say final velocity minus initial velocity, the answer will be in the same velocity. The unit will remain the same. So I mean the unit and the you are just dealing with the same quantity, so you don't need to change it to, or to introduce other fundamental quantity. Just use the quantity or the fundamental quantities that are there. So, and we already did the, what do you call it, the dimension of velocity. So the dimension of velocity, we found out that is L t raised to the power of minus 1. We just write t L raised to the power of minus 1 on top, then all over the dimension of is L t raised to the power of minus 1. Then we have the dimension of this t, which is time again, is t, capital T. So now we need to take this t to up, so that we write it as, or we write it as or in a form that has no this division sign or this division. So it would be L t raised to the power of minus 2. How it is t raised to the power of minus 2? As we know in indices, all those formula that has some things, or all the denominator, let me just say it technically, denominator, if you want to make denominator to appear as numerator, just attach negative power to it according to the power it has, or based on the power it has as the denominator. For example, if we have a over b and you want to make b to appear as if on top as a, you just say a, then the b now, but put indication which is raised to the power of minus 1, because anybody that is saying this will know or will understand. Okay, you just want to make the b and a on a straight line, or you don't want to write the division sign. That's why you write it as this, and this in this form. So this is the way to do it. Just take it and put negative power, and if it is a all over b raised to the power of 3, for you to make this a division sign disappear, or to make it linear, you just say a raised to the power of b minus 3. That's all. So here we have you understand from here that t raised to the power of minus 1 means that this t is originally below, because it is a denominator. It's just to make it appear as if numerator. That's why it has this minus or negative power. So it's just as L all over t, this t, and again you have another t there. Just add multiplication sign, this t times t. At the end of the day, you end up having L raised to the power of, or L over t raised to the power of 2 now. And for you to take this, or to make, or to write all this in indices form, you just say L t raised to the power of minus 2, as we gave example here. So that's just it. So we have the what do you call it? We have dimension of acceleration as where L t raised to the power of minus 2. That's all for acceleration. Now let's move to another dimension of force. We know the formula of force is just m, which is mass, times acceleration a. We already have the dimension of acceleration as L t raised to the power of minus 2. So now we just add the dimension of mass to the dimension of acceleration, they will end up having the dimension of force. So force, dimension of force will be dimension of mass, which is m, multiplied by dimension of acceleration, which is L raised to the power of, L t raised to the power of minus 2. At the end, you have m, then L t raised to the power of minus 2. This is dimension of force. Then the next item is the dimension of work. Work or energy. Work and energy are almost the same thing. So work is equal to force times distance. Let's say force times distance, they symbolize distance as just s. So force times distance. Now we already have the dimension of force as m L t raised to the power of minus 2. Now just multiply it by the dimension of distance. Okay, raised to the power of minus 2, then multiply it by the dimension of distance, which is multiply by dimension of distance is just L. What is L? I mean length. So dimension of L is, or dimension of length is L. So now you have all these, just multiply everything. If you know your indices very well, just know that, or just understand that there's 2a here, or L here. You just say is equal to m, then L raised to the power of 2, because you have 2 L's, then t raised to the power of minus 2. This dimension of work. This dimension of work. Then the next item is dimension of pressure, which is the last. So dimension of pressure or pressure. Dimension of pressure is equal to, or the formula of pressure is equal to force all over distance. Force all over area. Force all over area as the formula for pressure. Then for you to have the dimension of this pressure, you just say dimension of force, which we say that m L t raised to the power of minus 2 as the dimension of force, then divide by dimension of area. We treat the dimension of area earlier. We say the dimension of area is L raised to the power of 3. Now here's the catch. You have L above and 2 L's. Sorry, this is 2 L raised to the power of 2, which is 2 L's. If I expand this, I have m L all over this 2. This t raised to the power of minus 2 is negative, raised to the power of negative 2. That means it's originally denominator. So let's just put it down. We have L times L, because I want to do cancellation. That's why I'm putting the full form of this index form of L times L. So I have the full form, which is L times L. So L times L, then times T, because this minus T is denominator, but when you take it to the denominator side, it will not become minus again. It will remain as t raised to the power of 2. So now I will do the cancellation. L will cancel L. What remains is m above, or m on top, then L times T. This can be written as m all over L t raised to the power of 2. And also, if we take this to up, then you have m, then you have L, but now L here is just L raised to the power of minus 1. As we know that every raised to the power of 1 is just the same thing. So now it's L raised to the power of 1. But taking it to the numerator side, you need to indicate the power, because it will become minus. So L minus 1. Then t raised to the power of minus 2. So this is the dimension of the pressure. If we carefully observe the process or the step from the beginning, you'll understand that this is very simple, but you always need to pay attention or to be very careful about the cancellation, and you need to know your indices, and you need to know how to convert from one form to another. That's all we have for you about dimension, but I will leave you with assignment. The assignment will be on finding dimension of momentum. First assignment is find dimension of momentum. I will give you the dimension. I will give you the formula of momentum. Dimension of formula of momentum is equal to mass, then multiply by, let me separate this, mass multiplied by velocity. Then number 2, you have density. Go and find the dimension of density. The formula for density is just mass now over volume. This is the formula for density, and as you saw previously, for you to find the dimension of a formula, what you need is just the formula. Or for you to find the dimension of a drive quantity, just know the formula. Very simple. Just impute the fundamental quantities that make up the quantity, and you end up getting your correct, if you know how to do the calculation, or if you know how to do the cancellation and all the indices way of writing the dimension. Thank you very much. If you enjoyed this lesson, as always, please try to comment, try to subscribe and open notification button. Also try to like these lessons, and finally try to share this lesson to other people so that you help us grow My New Science School on YouTube. Thank you very much. See you in the next lesson.